Okay, guys, we start with quotients today. If you don't know what quotients are, quotients means dividing. Sometimes we look at quotients when we do this, we look at them as fractions. I know we're going to have another section later on fractions, but these are basically set up as fractions. And some of you already figured out that the rule for quotients is going to be very similar to the rule for products, because when you're multiplying, you do one thing. When you're dividing, you do the opposite. But I'm going to show you how it works, because again, I go back to the word expand. If you can expand, you can do anything. Expanding makes it easy. It's not the shortest. Oftentimes it's longest, but expanding will always work. So I'm going to show you here when you expand it. The very first one, we have 4 to the 4th power, so that means all these 4s, and 4 to the 2nd power, so we have all those. Now remember, anything divided by itself is 1. So if you have 4 divided by 4, those cancel, giving you 1, and that 4 cancels with that one. So now they're on the bottom, there's nothing but 1s. On the tops, there's 4s. So you have 4 to the 2nd power over 1. Now, in this case, we'd go ahead and simplify it at 16, but it's 4 to the 2nd power over 1. We're going to apply that same logic to the next one, x to the 5th divided by x. So we'll have 5x's on the top. We have 1 on the bottom. Remember, any number divided by itself, anything divided by itself is always 1. So that x divided by that x cancels out. We're still left with 4 x's on the top and only 1 on the bottom, the number 1 on the bottom. So x to the 5th divided by x is x to the 4th. Now that's a lot of writing, but we're going to kind of work through this. For the next one, I started with the expanded form, so I wanted you to get to practice writing it so you'd see it. Well, there's a 12, and there's a 4, and there are 1, 2, 3, 4, 5 x's on the top, 1, 2, 3, 4 x's on the bottom. Okay, so you can go backwards there. Now, when we start working it out, we can cross out or divide out these x's. Usually we just cross them out. One way to think of that, and as we start getting bigger ones like this, is you're smart enough, you realize when we cross them out, they're going to be gone. Think of this, if there's 5 on top, there's 4 on the bottom, are there going to be leftovers? And the answer is, of course there's going to be leftovers, because they're not the same number. The question is, are there more leftovers on the top or on the bottom? And in this case, if there's 5 on the top and 4 on the bottom, there's going to be 1 leftover on the top. So I always start with the quotient by drawing that line like that, and then I put my x where it goes. I still have the 12 and the 4. Now 12 divided by 4 happens to work out easily, but you can also look at that as reducing, something like that, but we'd simply write that as 3x. But I'd go through all that motion with that one to show you the next one. We have 4x to the 5th, y to the 6th, divided by 20xy to the 5th. I'm going to write it out, okay? I'm going to write it like 4 and 20. I'm not going to write all those x's, but I am going to put x to the 5th. I'm going to give myself a little more space so I can write some things out here. So I have this. So I'm going to start, and we're going to look at every little piece individually. Okay, x's don't combine with y's don't combine with x's don't combine with numbers. So I'm going to start by looking at the x's, 4 and 20. I'm sorry, I said x's. Looking at the numbers, 4 and 20. They reduce. 4 divided by 20 is not 5, but 4 is 1/5. So if I reduce it, I have 1 over 5. Now I look at my x's. I have x to the 5th and x. That means there's 5 on top, there's 1 on the bottom. If I cross them out, that's going to leave me with 4 on the top. So I'm going to go and put the 4 there. And then I'm going to look at my y's. I have 6 on top, I have 5 on the bottom. If I go through crossing those out, I'm going to have 1 left over, and that's going to be on the top, so it's y. So even though I wrote so big there, I can rewrite this as simply x to the 4th y over 5. That's a better way to write it. You don't need to put all those ones in there. For my next one, I have 14x to the 5th y squared, 10x to the 3rd y to the 5th, and again, I'm going to go ahead and expand it all. I have 14, I have x to the 5th, I have y squared. I'm giving myself a little space. I have 10, I have x cubed, and I have y to the 5th. Now, as I rewrite this, I'm going to still put my line. I'm going to start with the 14 and 10, which does not simplify easily. So I just reduce everything by 2, so it becomes 7 and 5. I have x to the 5th and x to the 3rd. Now in this case, I have 5 on top, I have 3 on the bottom. I can cross those out. That leaves me with 2 up here. Now this one's different. I have y to the 2nd over y to the 5th. Again, when I start crossing them out, they're gone on the top. That still leaves me with 3 on the bottom. So I end up with 7x squared over 5y to the 3rd power. It's okay. Sometimes you're going to have leftovers on top. Sometimes you're going to have leftovers on bottom, which is why, like I said earlier, whenever I start working one of these with a quotient, the first thing I do is I go ahead and draw that fraction bar. I may not need it like on the third example, but I may need it like on the other two examples. So I go ahead and write those out. So comparing each example, I'm sure what you noticed is that with the like bases, you can only compare like bases. I'm going to write that, even though you may not have written that here. I want you to realize, again, I want you to see it in writing, you can only compare like bases. If they have like bases, you simply could subtract the exponents. So x to the a minus the b. Now, the only problem with that is that it doesn't really work when you have like x to the fourth over x to the seventh. When you subtract it, you get x to the negative third. And you notice I didn't mention anything about negative exponents because they're weird. We'll get to those in a future video. So you can use that, but for now, again, if you expand everything, even this one, if I expanded this one out, all those x's, makes it very simple to cross out. 3 on the bottom, 1 over x to the third. Now some of you may even pick up how we deal with negative exponents, but we're going to get to that later. So now stop and work on the extra practice problems and see how you do. But do stop the video, don't just copy my answers. But I'll explain here on the other side. All right, so we had 2 examples here. Again, put your line, it doesn't kill you. Draw a little line there. If you have 4 x's on top, 2 on the bottom, that's going to give you, these are going to cancel, leaving you 2 here, so 2 on the top. You have y to the 7th and y to the 9th. There's 7 there, it's going to cut out 7 of them, leave you 2 there. So it's x to the square, x to the second over y to the second. For the second example, again, we're going to have 24 and 16. We're going to have a to the third and a to the fifth. We're going to have b, and well, that one doesn't have one. And we're going to have c to the fifth and c squared. So we can work through that. 24 and 16, 8 goes into both of those, gives us 3 over 2. We have 3 a's on the top, 5 on the bottom, so when I cancel them out, I'm going to be left with 2 a's on the bottom. There's a b, but there is another b, so it just stays by itself. And then we look at the c's. There's more c's on top, so there's 5 on top, 1 on the bottom, which leaves us 4 on the top. 3bc to the fourth divided by 2a squared. That should do it for quotients. Go try the rest of your activities, and you'll look at the next video soon.